The diagram shows a curve of y equals cos x and y equals sin x for x between 0 and pi over 2. The region R is bounded by these curves in the x-axis. Find the volume of the solid of revolution formed when R is rotated completely about the x-axis. Give me your answer in terms of pi. So here's what we have then. So basically we're going to spin this around here. And we'll get these disks and we need to find the volume when these are rotated 360 about the x-axis. So we'll need to divide up the disk into a series of disks because they change in terms of their height. From here to here they're going to be the height of sine, and from here to here they're going to be the height of cos. So basically, when does cos x equal sine x? Well, if we divide by cos both sides, we see that one is equal to tan x. And we know that tan of 45, or pi over 4 in radians, equals 1. So this point here is pi over 4. So what we've got then, so volume is equal to the integral of the area of this disk is pi r squared. The radius is the height, so that's y squared dx, between 0 and pi over 2. Which is equal to the integral between 0 and pi over 4 of pi y squared then. On this side it will be sine, so that will be sine squared. Plus pi lots of, and the second part of the integral will be pi over 4 rather, from here to pi over 2. And on this side, the region R, the heights are defined by the cos, aren't they? So it'll be cos squared. Okay. Right, so what have we got then? So it's equal to pi, the integral 0 to pi over 4. Now we need to replace this. Now remember that cos of 2x is equal to 1 minus 2 sine squared. And it's also equal to 2 cos squared x minus 1. So we should be able to rearrange this. So the sine squared then x. Move this over there, it would be 1 minus cos 2x. So leave that as is. Minus the cos 2x. But then you've got 2 sine squared here, so just divide by 2. So this is just a half minus a half. I scratched it in up there using the double angle formula for sine squared plus pi. The integral between pi over 4 and pi over 2. That should say pi over 2, of course. So let's put that in. And cos squared, well, if we look at cos squared then, here it will be 1 plus, won't it? Move the 1 over, it will be 1 plus is 2 cos squared. Divide by 2, we get cos squared is half plus half cos 2x. So just bear that in mind while just a bit of rough working here, so that we could remember what double angle formulas give. So it's half plus half cosine 2x dx. So now we can integrate, so it's pi. Half integrate with respect to x is x over 2. Now the integral of cos 2x will be sine 2x. Sine differentiates to cos, so we still need the minus there. A 2 will come out. We've got a half here, so we'll need a quarter. Between 0 and pi over 4 that should read, shouldn't it? So I've been a bit sloppy there. That should read pi over 4. We split it up. So there's the value. Plus pi of this value here. This one is again x over 2. And the cos with a plus was sine, the integral, this would integrate to sine 2x again. Sine differentiates to cos, but a 2 comes out, we've got a half, so we need a quarter, and this will be plus. And this will be between pi over 4 and pi over 2, won't it? So I think we're okay there. So let's not forget we've got a pi outside all the way through. Now top value, take bottom value for the first one, plus this pi, and then we do top value, take bottom value. So I've left plenty of room. Put pi over 4 in here, we get pi over 8, minus, and then it's sine pi over 2, 2 lots of pi over 4 is pi over 2, sine pi over 2 is 1, so it's minus 1/4. That's the top value. Put naught in, you get naught, and you get naught here, because sine naught is naught, and this is naught. Now this one, pi over 2 in here is pi over 4. Pi over 2 in here is sine pi, which would be 0. Sine of pi is 0. 2 pi over 2 is pi. Sine pi is 0. So that's that value. Take away the bottom value, put pi over 4 in. Pi over 8 then, plus, and then sine of 2 pi over 4 is the same as pi over 2. That's 1, so it's plus 1/4. So that's what we've got. So what have we got all together then? Let's just try and write it out. We've got pi squared over 8 minus pi over 4 here and here, plus pi squared over 4 minus pi squared over 8 and then plus pi over 4. So this cancels with this one cancels with that one, and it just leaves pi squared over 4. And there's our answer. Now it said, now find in terms of pi, so it's pi over 4, which is what we've got, pi squared over 4. Just looking at this and running through and double checking it all, just one error here. This minus, I ran through that, but I didn't run through the minus here. So this term here is actually a minus, which is not something you'd want to do really, if you could avoid it. So here we've got actually got 2 minus pi's over 4. So it ends up being minus pi over 2. So that's the final answer then. So it's very easy not to run the minus through the two terms. When we do, we get minus pi over 4 minus pi over 4 is also minus pi over 2. And we've got a pi squared over 8. Pi squared over 8 plus a pi squared over 4 here, that's it. It's just that single term, isn't it?